Thank you for attending DevOps for Java developers at InfoQ live event. My name is Ix-Chel Ruiz. I'm from Mexico. I live in Switzerland. I'm a Java champion, work for JFrog. I have collaborated in some books. The most recent one is the DevOps Tools for Java developers. So let's start with the DevOps part. I would like to share with you the 2021 State of DevOps report. This is the 10th report prepared by Puppet based on more than 2,600 responses from all around the world. The results are clear. Organizations practicing DevOps consistently report more frequent deployments, shorter lead times to change, lower change failure rates, and faster mean time to recover. They also self-define their evolution in their DevOps transformation from high to low. For 8 years, highly evolved DevOps teams have consistently demonstrated better performance across 4 key software performance metrics: deploying to production on demand, reporting change lead times and mean times to recover under 1 hour, and change fail rates under 5%. But far too many organizations reach a plateau in their DevOps evolution, and this has been a consistent trend of stagnation. Locally, plenty of improvements can be accomplished in 2 areas: platform and cultural initiatives. At the twin layer, the platform, increasing the self-service and seamless integration between different tools used on the software development cycle increases the adoption of DevOps practices faster. Highly evolved firms make heavier use of internal platforms from their engineers, enabling developers to access authentication, container orchestration, service-to-service authentication, tracing and observability, and logging requests. It is important that the process and the platform is well defined, integrated, and easily available for all teams to adopt. One of the areas that still present the most challenges is the new culture adoption. To create a mechanism to untangle teams, it is important to create initiatives to promote a culture of knowledge sharing. Teams who share common tooling, language, or methodologies can actively share best practices with other teams faster and more effectively. And lastly, all teams require a clear understanding of the IT infrastructure landscape. On the other hand, as Java developers, we have some advantages that we can leverage. For example, a very healthy ecosystem with mature libraries for testing metrics, observabilities, and whatnot, and build tools with scanning capabilities. We developers are consistently focused in 2 main things: improving the quality of the software that we build and trying to release more valuable features in each release version. Even more, we know releasing a new version is a routine operation where a consistent process can be followed. If we already are embracing the cultural change brought by the agile development style, adding new methodologies like DevSecOps, shift left, will enable the optimization of the entire software development process. Build, test, release, deploy, monitor, and observe the application in production. So, what is DevSecOps? DevSecOps is a set of security assessments where we have a lot of tools of practices in different categories. For example, static application security testing, Tools in this category scan source code for known weaknesses and insecure coding practices, code smells. Software composition analysis tools analyze software to detect known software components, such as open source and third-party libraries, and identify any associated vulnerabilities. SCA complements SAST by finding vulnerabilities not detectable by scanning source code. Dynamic Application Security Testing, DAST, scans applications in runtime. This enables an outside-in approach to testing all these applications for exploitable conditions that were not detectable in a static state. Web application firewalls monitor traffic at the application level and detect potential attacks and attempts to exploit vulnerabilities. Container image scanning tools can continuously and automatically scan container images within the CI/CD pipeline and in container registries. Cloud security posture management solutions identify misconfigurations in cloud infrastructure. And finally, shift left. Shift left only brings testing and security measures into the code development process as early as possible. So, moving towards us, the developers. I'm passionate about testing, and even when I have been advocating quite vocally about the benefits of testing in all its flavors, unit integration, contract, UI, end-to-end, REST API, acceptance, exploratory, I have to admit, sometimes it's easy to disregard their importance. Security. In the last years, very dramatic vulnerabilities have brought more attention to security dependencies early on the development cycle and involving us, not only the Q&A or security teams. There is another dimension that we haven't mentioned so far. For those of us that have decided to move towards microservices, we stand at the overlap of an architectural style which introduces the idea of multiple services, while bringing security and testing concerns at an earlier stage of the development cycle of each one of them. Martin Fowler once described microservices as an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, built around business capabilities and independently deployable by fully automated deployment machinery. Maybe with a bare minimum of centralized management of these services. And they may be written in different programming languages. The challenges: improving the quality of the software, releasing more valuable features in all aspects of the process, from requirements, specification, documentation, architecture, testing, security, automation, to collaboration between different tools, are multiplied. Micro, mini, or small services, potentially written in different languages, evolving at different rates as a whole different products. And communicating between them. So, changing some API contracts. So we need tools. We really need tools that make all that overhead easier to manage. So let's talk about tools. Or even better, let's first discuss how do we manage our contracts, because our APIs are contracts of communication between our different services. It doesn't matter the size. And if we're using one of the most typical protocols of communication, REST, then how do we define, document, version, deprecate, or even show some of our examples to our different consumers? I strongly suggest you to use the OpenAPI specification. It has really good tools for maintaining, publishing your documentation, and even creating automatic mocks or testing, verifying, generating code for the client or the server. So it is really interesting or important that you start using these standards. On the security part, bringing everything closer to the developer, I want to show you some of my favorite tools. Frogbot. This is a GitHub bot, a Git bot. Actually, you can use it with GitLab, GitHub, or Bitbucket, and it has different types of functionality. But the one that I like the most is when you open a pull request, it actually automatically scans your pull request for known vulnerabilities, and in case that exists, it will create a report telling you which component, what are the vulnerabilities found, and even if there is a version that actually fixes this problem. So even before you are merging the code into your repo, you have all this information at your fingertips. Another one is a desktop Docker extension that scans your Docker images and exactly provides you with a very cool report with all the vulnerabilities, again, the version, the known, and even advice from our security team. Our IDEs, in this case, I'm showing you IntelliJ IDEA plugin, JFrog plugin, that actually does the same thing. It scans your dependencies, in this case it's a Maven projects, and in your IDE it will tell you the vulnerabilities, the version, which components, even the reports. So we are lucky in the Java world. We have adopted the microservice architecture style with Gusto. There are several frameworks out there that support microservices, for example, the Spring Boot, Quarkus, Micronaut, Dropwizard, among others. And they provide their own testing libraries or leverage known libraries such as JUnit, Hamcrest, Mockito, AssertJ, or RestAssure. But I want to talk about my favorite tools. WireMock. WireMock is a simulator for HTTP-based APIs. Serverless visualization tool or a mock server. Runs a standalone process without the HTTP server in Docker or even in Docker. Proxying selective proxy requests through the other host. Matching criteria can be used. Has record, replay. You can simulate faults or have or define stateful behaviors. In version 232 released last December, the team introduced the ability to run WireMock without needing the HTTP server for a serverless deployment model. Another of my favorite libraries, RestAssure. RestAssure is a Java DSL for simplifying testing of REST, specifying request data. For example, path parameters, cookies header, multi-value parameters, and also verifying response data with ease, cookies status, pattern matching, body content in the different formats, measuring responses, supports authentication, OAuth 1, OAuth 2, Spring support. In version 4.50, they upgraded from Groovy from 3.08 to 3.09. Test containers. Test containers is one of my favorite projects out there. It's a Java library that supports JUnit tests, providing lightweight throwaway instances of common databases, Selenium browsers, or anything that can run in a Docker container. And it will create all the containers that you have defined, and while your tests are running, well, obviously it will run correctly. But as soon as they have finished, it will actually properly dispose of your resources. And in version 1.6.3, they introduced the K3S modules for testing Kubernetes components. Even if we have a healthy number of unit integration contract, end-to-end REST APIs, acceptance and exploratory test, we are still in a controlled and well-defined world, bound by our own imagination and assumptions of what could possibly happen in production. But out there, things may be a little bit different, or completely. How, where, what, how long, how fast is defined by our imagination, beliefs, technical capabilities, and assumptions. Though sometimes we're not really testing, or we're really not having a clue what is going to happen out there. So sometimes we need to test in production. I know, sounds so wrong. We should say, observe closely our services in production and understand better their system state using a predefined set of metrics and logs. Monitoring applications let us detect failures. Monitoring is crucial for analyzing long trends, provides information on how the services are growing and how they are being utilized. Observability, originated from control theory, measures how well you can understand a system's internal states from its external outputs. Observability uses instrumentation to provide insights that aid monitoring. An observable system allows us to understand and measure the internals, helping us figure out the cause from the effects. There are three base pillars. Traces. Traces track the progression of a single request. That is a trace. And it's handled by a service that make up an application. A request may be initiated by a user or an application. Distributed testing is a form of tracing that transfers process, network, and security boundaries. Metric is a measurement about a service captured at runtime. Logically, the moment of capturing one of these measurements is known as a metric event, which consists not only of the measurement itself, but the time that it was captured and with all the associated metadata. A log is a time-stamped text record, either structured, recommended, or unstructured with metadata. While logs are independent data source, they may also be attached to spans. Okay, so now let's talk about tools for monitoring and observing. I believe in open source and promoting standards in the industry. Most of the times, I will join the efforts that foster and sustain an ecosystem of open source projects or tools that implement standards. Hence, enters the CNCF, the Cloud Native Computing Foundation. The Cloud Native Computing Foundation seeks to drive adoption of technologies and techniques by fostering and sustaining an ecosystem of open source, vendor-neutral projects, with technologies necessary to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. For example, container service meshes, microservices, immutable infrastructure, and declarative APIs. By focusing on techniques that enable loosely coupled systems to be resilient, manageable, and observable with robust automation. The goal is to allow engineers to make high-impact changes frequently and predictably with minimal tool. One of the projects that is most famous from the CNCF as a graduated project is Kubernetes. Now let's talk about the scheduling and orchestration. In orchestration, well, probably you are using Kubernetes in your projects. It's an open source graduated project of the CNCF, mostly written in Go. And in the CNCF, you will have all these really nice cards displaying what is the composition, where you can find the different projects, the license, everything. For example, in observability and analysis, we have all these tools available: Open Metrics, Prometheus. Inside tracing, we have Zipkin, Jagger, or Open Telemetry. In logging, Grafana Loki is what Prometheus is for monitoring, Loki is for logging. Well, you probably have also encountered Prometheus in your own projects. This is an open source monitoring system developed by engineers at SoundCloud in 2012. It was the second project accepted in the CNCF Foundation after Kubernetes, and also the second one to graduate. The Prometheus monitoring system includes a rich multidimensional data model, a consistent, powerful query language, an efficient embedded time series database, and over 150 integration with third-party systems. My only word of advice is cardinality is key. Open Metrics creates an open standard for transmitting cloud-native metric scales. It acts as an open standard from Prometheus. Was created in 2017. Since then, Open Metric has published a stable version 1.0 of the specification that is used in production by many large enterprises: GitLab, DoorDash, Grafana Labs. Open Metrics is primarily a wire format, independent of any particular transport for that format. The format is expected to be consumed on a regular basis and to be meaningful over successive exposition. This standard expresses all system states as numerical values, counts, current values, enumeration, and Boolean states. Singular events occur in a specific time. Open Telemetry is just a new way to visualize data across application. This project aims to change how we use instrumentation without requiring a change in monitoring tools. It's a collection of tools and features designed to measure software performance. It is the amalgamation of two open source projects, Open Tracing and Open Census. The CNCF developed Open Tracing to provide a vendor-agnostic standardized API for tracing. Open Census was the internal traceability platform from Google that later evolved into an open source standard. Open Telemetry is an incubating project, combines the strength of both of these standards to form an unified traceability standards that is both vendor and platform agnostic. It is now available for use across different platforms and environments, provides APIs and SDKs among other tools to measure, collect telemetry data for distributed and cloud-native application, and allow exporting the data to other visualization tools. So if you go right now to the CNCF page, you will have the whole entire ecosystem of all the projects in each one of the categories. I hope I have shown you something new in this session. Please contact me, provide me feedback. I'm always open to feedback. Thank you very much. Have a lovely day.
Hi, thanks for the great presentation. I see as well that you have already answered a few of the questions in the chat about chaos engineering. That was actually one of the questions I had for you as well. And I would like to start with actually, first of all, asking our listener if there's anything that you want to ask. Please feel free to add. Yeah, I see. Yeah, no, it's still your last answer. Now, I will start with a couple of questions from my side. Are you muted right now? Because I don't hear you. Uh, I cannot hear you, but I don't know. No. Do you have both the button as green right now? I would suggest maybe to try to. The only thing I can think is to turn audio on and off, both on and off. But I think you already tried.
Now I changed my.
Now I can hear you. That's great. No worries. We still have time for our Q&A. No, I'm quite old Java developer. I don't consider myself a Java developer anymore because it's too many years that I don't write enough code to pretend to be anymore a Java developer. But I was curious. I definitely agree with you that the ecosystem in terms of tools and options for Java developers is definitely more mature than for other platforms. I was wondering if there's instead anything that as a Java developer actually in this space, in the DevOps space, is actually missing. I mean, things that from other languages, from other technology, you feel like, oh, we are basically lagging behind.
Well, actually, the answer is very close to what they ask in the chat. There are no differences. There is really not a platform right now for the entire thing about ecosystem for in the ecosystem about like observability and monitoring. You actually need to pick and choose, and that means that we still don't have like a package like use all these technologies. This is the sensible configuration. This will provide the most seamless integration between tools. That doesn't exist. We're still building that. So it's not like we're lacking that in the Java developer only. I think we're lacking that in the entire development world.
That's
but
a
we're
very
running.
good point.
But we're running towards that.
Yeah, is that I think is actually a very good point you're making, because I mean, you close your presentation with that amazing slide with the full ecosystem. In one sense is, wow, it's amazing what is out there. On the other side is, oh, as a developer, where should I start? Because if I attend this presentation, I feel amazing, I want to do more. One of the questions I will immediately have is, okay, how? That's the very first. And I see as well the question in the chat as well is, you mentioned many different tools. I think he's asking if there's actually a list or something. I think you can probably then action on that.
Sadly, I mean, I'm going to give you the consultant best answer. It all depends. And it all depends. It all depends. If I go to an organization and see their technology stack. There are tools that make more sense because they are covered in a broader aspect. As I said, right now, we don't have the pre-selected menus that will work on XJZ cases. We still don't have that. I mean, that's something at the foundations level we're trying to do. On one side is create the standards so the vendors implement those standards and you can migrate from one tool to another as painless as possible. But on the other hand, we don't have like the synergy. And if you have decided to use I don't know, Jagger instead of Zipkin? What is the difference? How difficult is that going to be? Envoy, I'm using Envoy for the proxying on my microservices. So things like that, it is more about somebody actually trying them together and saying this has lower impedance in the communication. So honestly, I hate to give this answer, but it's a trial and
Depends.
fail
Okay.
kind of thing.
Okay. Yeah, I think is we all probably want to have a magic solution, but the magic solution is still probably not there. I would actually like to go back to the beginning of your presentation when you present the results of the survey from last year, and I found that really interesting what you say about the stagnation, more or less, of the number. What do you think is the main? What do you see as the main reason for that? I mean, I get that people are, I mean, for many years, the message I got is if you do DevOps, things are getting better. The results are
Mhm.
there. You see numbers are better. Your downtime is lower. Your production is faster. You go live quicker. Everything is great. So the silly question is, so why are people not doing it more? Because they're afraid, because they're lazy, or because actually you reach a barrier that you do a bit and then you don't take the next step? What are the things that are slowing down, you think, the adoption?
There are several reasons. One, as I said, there is no platform still. Like, and then people are like, they try and sometimes they fail a little bit, or there is a little bit of complex connecting all these applications. On the other hand, is when people, and I have gone into the different organization and ask who, I mean, who is involved in the DevOps culture more actively inside the teams, and nobody says me. So even us as developers, we kind of started with the wrong foot. We, because we were building the software and suddenly from top they came and say, well, now you also need to take into consideration security. Now you also need to take into consideration your build process. So instead of using it externally, now it's going to be a pipeline inside your code, and now you're responsible for this. And then when we're saying about security, then we start using these tools like OWASP or AnyBots, Dependabots, or Security Sneak, JFrog, whatever. And suddenly we have lines like, honestly, hundreds of vulnerabilities and warnings. And you are like, do you want me to fix everything? Honestly, is that the message? So now I need to learn more tools. Now I need to have an overview of the entire process. Now you are telling me that I have to deploy into pods, containers. Do I need to know that now? Suddenly now I need to worry about C groups, about different users. So it's crazy. So many developers said, I'm a developer, I know the DevOps, I don't want to go into that trip. So having said that, uh, the problem of stagnation is we are overwhelming a lot of our developers. Sometimes we don't have the platform set in our organizations. It's too bumpy already. And the on top of that, um, inside the teams, because DevOps requires a lot of intercollaboration between teams, and people are not sure about what are their roles and their needs
Different.
when you start talking about that. So
That's a very good point. I see as well that the listener basically they are still focusing on the very same problem, that is, as you mentioned, is it's pretty hard to choose what you need and how to do it. I see as well they're asking for blueprint. If there's any blueprint, think again about that. I think that the last slide was something that shocked many, many of us, because it's really cool to see a huge big poster that probably could cover an entire wall. And that's, as you mentioned, is then pretty hard to do the next step. So I think I was asking if there's any blueprint, as you have, for example, for the ecosystem, like
I
visual blueprints or.
I can point you to several, and I will post some of these resources later on. I will send them to you so we can add it to probably the description
That would be great,
about
yes.
yes about success cases, like what is the technologies that we use so to migrate x amount thousand of services or x amount thousand, which they are, again, they are the thank goodness it is not a green future for us. They are some really good examples of good migrations or group or very good DevOps stories. So I will point them out. And but as I can as I cannot tell you this is like the golden recipe. Not even like three different menus. Sadly, and that actually that's just something that, because I belong to the CDF Foundation, that is something that we are working on, because it's not only me as a developer which who feels overwhelmed, it's a lot of developers. We still cannot suggest something that is sound complete, and that is annoying.
So that's the pain. I was thinking as well in that sense, as you mentioned a lot, the topic of vendor neutral project, that's the essence of the entire idea, is thinking as well about of the comments I saw. So it was like, can I take some shortcut? If I'm using basically one cloud provider, if I'm migrating to the cloud, how bad is if I try to, for my DevOps journey, with, let's say, vendor lock-in or anyway use service that maybe are not vendor neutral, but will make my cloud adoption faster or quicker, or maybe previous knowledge of the team totally against it, or you see a point for it.
I see a point of it, and actually, I will tell you something that it's even a little bit increases the complexity a little bit. For example, if you are already doing microservices and using cloud, and um, you may want to have different vendors for some of your critical services. So it's not even like you are trying to avoid vendor locking. You are also having another level of complexity is being aware of the configuration between different clouds providers. And not only that, checking that all your configurations are safe or well configured or equally configured even between the two. And probably people say me like, well, as a developer you don't need to do that. That's totally ops should take care of that into consideration. But there are some things that will actually have to be changed or modified or exposed in a different way when we are building our software. So that's actually one of the benefits to the entire organization, because we need more knowledge, probably not in-depth knowledge. We are not going to be the ones that have the deployment keys or deployments roles, but our knowledge on the actual challenges that they face will make us reconsider some of our architectural decisions or implementation
Let's see.
strategy.
I think we're running out of time. We have time maybe for one last question. There's something really that fascinated me when you talk about shift left and all the security part of the DevOps. That is something I noticed that in the last few years, but not just in that area, but in general, there are more and more, almost all on the cloud provider, tendency towards machine learning, artificial intelligence service that basically I'm thinking about, oh yeah, well, I'm going to find your code security vulnerabilities using some machine learning algorithm. And I can see that maybe they are not mature yet, but that's a direction. Do you think that's going to take place? There's going to be overlapping with machine learning as well in this area on the DevOps side or not?
I think it will. It will. I mean, static code analysis totally will benefit from figuring patterns faster,
Okay.
and what we define as code smells, trying to um, the, reduce it, and even what some of our IDEs are doing, like this is repeated code, do you want to extract it? So things like that, I think we will benefit in the long run. Things that are really clear that we may improve either because of complexity of the code, or because we are not, or easy refactory things, we're already benefiting from it. Maybe not in the full blown
machine.
yes, but we are, and I think machine learning there will help us a lot. You were mentioning about GitHub Copilot,
Yeah.
and
I was thinking that as well. The next step is much more that I don't see it as you write the entire code, but I can see the appeal of starting to see some code there is starting as a base. So I don't know how it's going to fit for a DevOps.
Actually, I think in some places it will be very beneficial. In others, it will start conversations, but more about responsibility, authorship, and because
Okay.
yeah, but I think it's going to be a good influence.
Well, unfortunately, we are really running out of time. I have to thank you for the great presentation and say bye to everyone, say thank you to everyone. And it's going to be nowadays short break, and then it's going to be the second session. See
Okay,
you soon.
thank you. Thank you very much for
Bye.
being here. Bye.